So now that we've been studying measures of central tendency, and now that we know how to find like the middle of a set of data and use that to kind of represent a set of data, we do want to kind of talk about, once you know where the center of a set of data is, how can we talk about how spread out the data is? So we're going to talk about some different measures of spread. So first, we just want to look at these sets of data here, and we want to find their mean. Now, if you ever see this little symbol right here, it's a Greek letter. It's mu, the Greek letter mu. We do use that symbol to represent mean. It's one of the symbols that we use to represent mean. If you remember, the other one was the X with the bar over it. So those are both symbols that we use to represent mean. Let's find the mean of these three sets of data. So if you remember, mean added up and divide by how many numbers there are. So 2 plus 2 is 4. 4 plus 3 is 7. 7 plus 4 is 11, and 11 plus 4 is 15. So that's our sum, and then we have to divide it by how many numbers there are. 1, 2, 3, 4, 5. So there's 5 numbers. So this one has a mean of 3. 0 plus 0 is 0, plus 5 is 5, plus another 5 is 10, plus another 5 is 15. There's 5 sets of numbers, and so it's going to have a mean of 3 as well. So we've got a mean of 3 and a mean of 3. 3 plus 3 plus 3 plus 3 plus 3 is 15. Divided by 5 is 3. So we've got these 3 completely different sets of data, but all 3 of them have a mean of 3. So the mean is not really going to give us the full picture of these sets of data. It gives us the middle number in the sets of data, but this one is very different than this one. So while all these have the same mean, they are spread out differently. Which trial has measurements that vary the least, the ones that are the least different from the mean? Well, that would be the third one. If you remember, this one was the one where all the numbers were 3. So the average turned out to be 3. They're all exactly the same as the mean. But the trial that the measurements vary the most from the mean would be the second one. Because if you look, we've got 0 and 5. That's as far away as we can get from the mean out of these sets of data. So it's spread out really differently. So what we would like to find is a number that expresses the fact that the values in the third trial are all very near the mean, and the values in the first trial are somewhat near the mean, and the values in the second trial are really far from the mean, because those are 3 very different sets of data. So what we are going to talk about today is ways that we can find these differences. So we want to find the values from the first trial about how far those numbers actually are from the mean. So we just need to know, what is that distance? So the numbers from that trial were 2 and 2, 3, 4, and 4. So we just want to take all of these and we want to subtract what the actual mean was. So 2 minus 3 is -1. 3 minus 3 is 0. 4 minus 3 is 1. And 4 minus 3 is 1. So if we add all this up, I get -1 plus -1 is -2, -2, -1, 0. So I got a sum of 0. Do you think the sum would always be 0 or never be 0? Well, that does depend on our different sets of data. We start talking about sets of data with hundreds of numbers. You're not always going to get 0. However, obviously, never be 0 is not an option, because we just got an example of where it could be 0. However, this poses a problem. If it ever balances out completely, which a lot of times it will, if we look at our data sets up above, we have some that don't and 2 that do. 0 kind of messes up our numbers. So what we do to compensate for this is we get rid of the negative numbers. And the easiest way to get rid of these negative numbers is to square everything. So what we want to do when we're measuring spread is, first, we want to find the distance of all the numbers from the center, from the mean. So that's what we're going to do first. We're going to find that distance, but then we want to square it. Because when we square it, any number squared is always going to turn out to be positive. So if we get everything to be positive, it just gets rid of that possibility of getting 0 there that's going to mess us up. Now, it doesn't mean that we're not still going to get 0 sometimes, but in order for us to get 0, it would have to be a situation like the third data set, where everything is equal to the mean. And that has a very special meaning. So, that is still possible, but at least it's going to tell us something useful. So for this particular problem, what that means that we want to do is we want to take all of these numbers that we got over here and we want to square them. So let's square everything. -1 squared is 1. And -1 squared is 1. 0 squared is still 0. 1 squared and 1 squared are both going to be 1. And now we want to find what is the average distance that these numbers are away from the center. So again, we want to find the mean. So that's what we're going to do. We're going to find the average of all of these numbers. And so that's what we're doing right here. So when I take 1 and 1 and 0 and 1 and 1 and I add them all up, I get 4. And then 4 divided by 5 is going to be equal to 0.8. This number is what we call the variance. All right, variance is a measure of spread. And what it is it's that average squared distance from the mean. It is, however, still the squared distance. We did have to square everything, so we didn't have those negatives. So it's not exactly the average of the distance, because we did have to square it. So as far as our units of measure are concerned, since these were, beans, basically, technically variance is going to be in beans squared. And so beans squared is not our original units. So we don't really use variance very often because it changes, but it does give us a story. So when we want to find the real measure of spread, the measure of spread that we use the most is called standard deviation. Standard deviation is going to be that measure of how far out are these numbers spread. What is their distance from the center? And all we need to do to get back to our original units of measure, if this unit of measure is squared, really the fix to that is to take the square root. We do have a symbol for standard deviation. It is this Greek letter. You're going to see a lot of Greek letters in math. This Greek letter is sigma. It's a lowercase sigma. Who knew there are uppercase and lowercase Greek letters? Okay, so this is the lowercase sigma, and that is the symbol that we use for standard deviation. And all it is the square root of that variance. So we found that variance, and now we want to find the standard deviation. So we are just going to take the square root of that number. So I need to take the square root of 0.8, and we're going to round it to 4 decimal places. So 0.8944. All right. So this is going to be our standard deviation. Now, what does the standard deviation actually tell me? So, typically, the standard deviation and variance are found using the calculator. This was a process. We went through this whole process, and this is what we're doing. We're measuring that distance from the center. So we subtract so that we can find all of our distances. We square them so that we can get them all positive. We find the average of that, because that's what we're really looking for, is that average distance. And then we take the square root of it so that we get rid of the square, basically. And that's going to give us this idea of what is the average distance away from the center. Things that you want to realize. The larger a standard deviation, the more spread out your data points are. The smaller your standard deviation, the closer all of your data points are. I do want to point out that that process is a rather long one, and so we typically don't want to do that by hand. We do generally want to use our calculator to help us find that information. So I want to show you how to do that. If you remember, on your calculator, the stat menu is where we enter all of this information in. So if we go to stat and edit, we can enter in that first data set, the 2234441. And this is what we just found the standard deviation for. But if you quit and go to stat, it's going to be in the same place where we found mean and median, the 5-number summary. It's under those one variable stats. One variable stats is where you're going to find that. This was where we got our 5-number summary down at the bottom. But if you look up at the top, it also has the mean and it has the standard deviation. Remember, it's that sigma symbol. So when you've got that sigma symbol, that's going to be your standard deviation. So there's the sigma of x, and that was the standard deviation that we got for our problem, 0.8944. It has the mean as well. And don't forget, if you scroll down, you get your whole 5-number summary. So all this information can be found. It's also good for finding the variance, because if we just remember, all the variance is that squared. Standard deviation is the square root of variance, so if I just square that number, I can find the variance as well. So you can use your calculator to find both of those things. And so this is how we can use our calculator for it. So let's do that to find the standard deviation for our other sets that we had up here so that we can compare them. All right, we're going to find our standard deviation for the other sets. We found it for the first one. Let's find it for situation 2 and situation 3. So I just go back to my stat edit. And I love this menu because it just lets you type right over what was there. So I don't even have to delete anything. 0, 0, 5, 5, and 5. So this is going to be our data set. If I go back to stat, calculate, in one variable stats, it tells me the mean was 3 again, but this time I have a standard deviation of 2.4495. 2.4495 if I round. And then our variance, we said we just take that number and square it. So I can take that number, 2.4495, and square it. That's going to give me my variance of 6. A variance of 6. So now we've got a standard deviation of 2.4495 and a variance of 6. Let's do it for the last data set here. So stat, edit, and then we're putting in this last data set, and it was all 3s. So we have 5 3s. We quit. We go to one variable stats, and we see our mean, and we see that our standard deviation is 0. So a standard deviation of 0 and 0 squared I can do in my head. That's a standard variance of 0 as well. So after we calculate and we compare these numbers, what can we say that the variance tells us about the situation? You may notice that the one where all the numbers are the same as the average, that had a standard deviation of 0. That's what that meaning is. If your standard deviation is 0, there is no variance. It doesn't vary at all. Everything's the same number. The first set, they were a little different, so it had a standard deviation of like 0.89. So there was some difference, but there was one that was the same, it was still fairly close. The ones with the 0s and the 5s, they were a whole 2 off. That was a bigger standard deviation. That was more spread out. So standard deviation is helping us to measure what is the spread of the data.